Good morning. Good morning and welcome to the O-Scope Wizard. I am Gabe, the O-Scope Wizard, and thanks for joining early to the guys in the chat, the folks in the chat, letting me know that it is nice to see a show that doesn't look staged. And my joke was, staged? This show barely looks planned. Last episode, we had a pin break off my Raspberry Pi. Mid-show, just a ground pin tore out of its solder hole. Its place of purpose, and decided it was going to strike off and try to journey out, which was less than ideal for the power circuitry of the Raspberry Pi. As you can imagine, a ground pin is fairly pivotal in the performance of the power system because that current goes out and it has to have a place to come back. It's got to be a loop. That's how the current works. And I did fix it. Through a series of pretty awful solder jobs. I have it on the Raspberry. I have the ground pin reconnected to the Raspberry Pi, so presumably we could make this work, and we will try to make it work. But before I do that, Band Shirt Tuesday. I got a new band shirt. This is one of my favorite bands of all time. It's a little folk group called 9 Inch Nails, and this is their Add Violence machine with all kinds of crazy kind of steampunk-ish knobs and dials, and it would be kind of cool to make the picture on this machine, like make a physical thing. Presumably they made a physical thing, but I could probably make a physical thing. Like maybe that's what the next audio system could be, like like maybe we could make an audio effects pedal. That might be kind of cool. But again, I'm Gabe, the O-Scope Wizard. Thank you for joining me on Band Shirt Tuesday. You probably didn't even realize it was Band Shirt Tuesday, but every Tuesday is Band Shirt Tuesday. Go support a band. Get that music flowing. It's awesome. Now, to the show. I have my timer, so I'm going to stay on time. I'm going to stay on track. We're going to start at 20 minutes. I think. Start. The beep let me know that it started. And we are into it. We're deep into it, folks. I should begin at the beginning. I've been trying to begin at the beginning, and it has been difficult. I should probably turn off my browser window. There we go. My question today is, can our battery power our new Raspberry Pi Zero W? So this is our current Raspberry Pi Zero W. And it is all stacked up neatly with a lot of different components, but one of the components that it does not have is the battery. After I resoldered the power pins on the bottom, let me turn off the words. We turn off the words so that we can see the pictures. After I resoldered the power pins on the bottom, I was not able to get the Raspberry Pi to successfully boot up with the battery attached to the back. I'm not exactly sure why. It could be because the pins on this side are not even, and so there's a chance that something might be shorting on the battery's board. Here, there's a bunch of empty pins, and some of which are even connected. That could be a problem. This ground pin could still be giving me a problem. It's not, let's see if the camera can see it. There is one pin that's not like the others. One of these pins is not like the others, and it is the pin that I repaired right there. That ground pin, just the pad was destroyed somehow. So with that in mind, I purchased a new Raspberry Pi, and I thought today that I could just open it up, we'll plug it in, we'll see if our battery works with our new Raspberry Pi and can actually boot, and maybe we can go to the next section of the project, which is actually right here in the browser window. So do we want to see me open it? There there's a weird market for unboxing videos. I'm not sure how serious people get. Oh, it's this little tab? I can actually just pull that and open it. Ah! One of the problems that I have with the Raspberry Pi, I don't have many problems caused by the Raspberry Pi. Most of the problems are caused by the Oscope Wizard himself. But you can only buy these one at a time. And I'm sure it's because they don't want people using these as, manufacturing stand-ins. These are definitely supposed to be hobbyist projects and to help education. But here's our new Raspberry Pi 0W H. All-important H here. The all-important H means that hopefully the pins are soldered on. Because, goodness gracious, my soldering skills are trash. They're trash. Some people brag about them, and I used to brag about my soldering skills. There was a time when I could solder a bond wire to a decapped silicon chip, which, if anybody's ever tried to solder anything super delicate, that is maybe the most delicate. It's like it's trying to, an unbagging video. It's a new trend. It's the new trend. We only have bags here. We're the Oscope Wizard. Anyway, if you've ever tried to solder a bond wire, it is sort of like trying to solder a hair to a hair. And I have done it successfully once, but I don't think I could do that anymore, especially with my current soldering iron. So this is the new Raspberry Pi WH that has the header pins already soldered in. I think most of my problems with my old Raspberry Pi were from the soldering of my header pins. I'm not sure if I got a good spot on it. So let's disconnect the old Raspberry Pi. One of the beautiful things about the Raspberry Pi is you just pull one out, you stick the SD card in the new one, and you keep rolling. Hopefully, that's the idea. That is definitely the idea. So we will pull this Raspberry Pi out delicately, so as not to do any more damage to any of our components. Here's the old Raspberry Pi right here. Here's the new Raspberry Pi. Looks like we got the same memory chip, the actual same vendor and everything. Everything looks pretty identical, which is how it's supposed to look. Except their soldering for their pins is much cleaner than my kind of janky soldering. So let's set this Raspberry Pi aside. Like Mr. Rogers taking his work shoes off and putting on his play shoes. Which Mr. Rogers' play clothes were pretty formal. I would consider those work clothes. His play clothes were my work clothes. Mr. Rogers had a very high standard of clothing. I mean, he pulled off work clothes to put on slightly more comfortable work clothes, I would say. He was serious. Now, I'm putting on this whole contraption. And what is this contraption? Let's talk about that. I've got my breakout pin for my GPIO that I've shown a bunch. And this is what is this called? The re-speaker from Seed Studio with a whole bunch of E's. And we will get into that, hopefully, now that this is connected. I want to go ahead and connect my battery because that's a pretty big component of this whole design. So I kind of want to get the battery on in there. And the battery would go. The problem is my battery turns on all the time, and I don't want it to be on. Turn off battery. All right. Let's plug it in. Okay, you can see the battery's on because the Raspberry Pi is like, oh yeah, sure, we'll boot up. Sure. On my last Raspberry Pi, after I'd done my soldering, my battery was working with the Raspberry Pi, and then after I did soldering, my battery was no longer. It wouldn't boot the Raspberry Pi. That's why it made me think that it was to do with my soldering, because before my soldering, it worked, and then post my soldering, it no longer worked. Usually when that occurs, when you are the cause, when you do something to change your system and it no longer works after you do your fancy thing, whatever that thing is, you were most likely the culprit. All right, a couple of screws in here just to hold it in place. We don't have to get it fully mounted today. We just kind of want to hold it in place and see if it boots up. It looks like it's booting. It does look like it's booting. I want to turn it off though. Through a series of button presses, can I turn you off? If I double tap you. Oh, there we go. That's what it is, double tap. I don't know. Again, one button to do everything. It's like the opposite of the Lord of the Rings. One button to rule them all. Except nobody knows how to work the button. So it's super complicated. I guess nobody knew how to work the ring either in the Lord of the Rings. Okay, we are booting up. It is annoying that the battery pack keeps turning back on. That is annoying. I wish there was a, you know what would have been a slightly better design? Instead of a button, a switch. This is a place where we are, sadly, a bit under-engineered. Usually we're fabulously over-engineered, and today, sadly, a bit under-engineered. Okay, have that plugged in. We have an HDMI cable to see if it will boot, in fact. Let us observe the HDMI cable. I think I actually have to have the cable plugged in for it to spit anything out to it, so double tap. No, maybe not when it's plugged in. Maybe not when it's plugged in. Okay, go. Oh, there we go. There we go. That looks promising. The only part about that that's not promising is that I think it might have rebooted. How are we looking? All right, we're booting up. That is all good. And will it boot all the way up without rebooting? Come on. Come on, Raspberry Pi 0WH. That's like the Raspberry Pi's middle name, and it's like when you're in trouble. My middle name is Thomas, so it'd be like, listen, Gabriel Thomas, when you heard your middle name as a kid, that was serious business. That was like, let's assess the situation. We are clearly way out of bounds of where we should be, and we probably need to reassess our lives and figure out, are we doing something wrong? Because if our parents said our middle name, oh my good. I wonder if that's a cultural thing. In other countries, if they say your middle name and you're a kid, are you in the poo-poo? Are you really bad? Is it going to be a bad day for you? I am curious. I wonder if that's true. I'm going to plug in my little remote keyboard and mouse and log into my Raspberry Pi so I can find out what its IP address is. And I think it might be working. Let's see. The login is Pi, and the password is Raspberry. Is there anybody in the chat from another country that could tell me if your middle name means trouble? As I try to figure out the IP address of my Raspberry Pi. Did I type it right? Okay, host name. What is it? I'm like out of the frame. Did I type that wrong? I might have. Hostname -L. I think that's right. What if I just type host name? I can't. I got the screen so tiny I can't see it. Raspberry Pi. Let me just see if I can SSH into this thing. That's the trick. Can I SSH into my Raspberry Pi? What is the IP? How do you get an IP address, folks, of the Raspberry Pi from the command line? I thought it was hostname -L. Let us see. You know who knows how to get a host name? Who knows how to get the Raspberry Pi IP address from the command line? Google does, because Google knows everything. use the terminal, boot to the command line, and type hostname -L, which will reveal your Raspberry Pi's host name, which is what I believe that I was doing. Host name dash, is that a dash? It is so tiny. That, maybe not, maybe that's not a dash. Maybe I'm typing something wrong. Maybe it should be dash L. Or what if it's host name dash, wait. What if it's dash I? Dude, host name dash I. What? Is it not on the, it's not on the Wi-Fi? All right, Raspy. Let's get this, sudo Raspy config. Is it Raspy? Maybe it's Raspy dash config. Yeah. There we go. There we go. You know what? Maybe I need to move this so I can actually see it. Let's make it a little bit easier on my old eyes. Okay, network options. Are we not? Let's connect everybody. Guess I probably need to blur that out in the actual live, the live show. I'm not telling you my password though. You couldn't tear it from my cold, dead body. I think that'll do it, right? The other thing that I probably need to make sure is that SSH is enabled. Yes. I would like it enabled. Is it enabled? SSH is enabled. Okay, let us finish. Now if I do hostname -I, now if I do reboot, let's see, we'll let it reboot, see what happens. See if we can get our IP address and it onto our network so that, yeah. I thought IP config, but that is I believe IP config might be a totally Windows-centric command, which the Raspberry Pi would, of course, ignore on account of it being non-Windows. But let's talk about the direction that we actually want to go with this project, because we are trying to make an IRL real-time subtitle necklace. That's the idea. We want ultimately this project to be offline speech recognition. This guy used a Raspberry Pi 4 with the respeaker, but I'm going to try it with the Raspberry Pi 0, which drastically reduces the horsepower available me. But he is using the exact same respeaker Pi hat that I have, and he, all importantly, goes through and tries it with an offline speech analysis package. I have watched other Raspberry Pi projects for speech analysis, and they used online cloud-based voice analysis packages like Google or Amazon, and that's cool if you have a network connection, but a lot of times you're going to be outside of, out of the range of Wi-Fi, or maybe I don't want to have to hook my Raspberry Pi up through my phone's hotspot. It would be nice if the Raspberry Pi could just do this all on its own, so he used what looks like a package called Deep Speech. And then he found that the Deep Speech algorithm was able to analyze WAV files, so he did it on WAV files, not on a stream of text, so that's going to be or a stream of speech, which will be a little bit different, but it was able to analyze the WAV files a little bit faster than the length of the WAV file, which gave me hope that I could potentially make this real time. He did it on, again, a Raspberry Pi 4, and the Raspberry Pi Zero is quite a bit less beefy than the Raspberry Pi 4, but I'm going to try to basically follow his instructions and go through and see if we can make this happen. Like, I'm going to recreate what he has posted here on the Seed Studio blog to see if I can make it occur on the Raspberry Pi. That's basically my instruction set. I'll post this link that I'm going to be using in case you want to get a ReSpeaker and a Raspberry Pi, and you don't have to get the battery. The battery is proving to be, weirdly, the most difficult part. I don't know what the deal is with the battery. Let's go and see if we're booted up. We are booted up. We are booted up. Let me see if we are on the network. You know what? I have technology. I have technology to show me the IP. In fact, it just showed my Wi-Fi was just like, yo, there's a Raspberry Pi on your network, which is a good sign because I wanted a Raspberry Pi on the network. And now is it not going to be listed? Oh my gosh. Oh my gosh. I don't see it listed here. Why? Why? Let's see if we log in. Well, let's use my keyboard. Pi. Raspberry. All right, we're logged in. Does it have the IP address there? Does it have the IP address as I'm logging in? Don't see the IP address. Yeah, there is a question in the chat. How can something be faster than real time? Well, first of all, time travel. Oh, there's the IP address, 192.168.86.57. Yes. Yes. Faster than real time. This guy, yeah, faster than real time. That is super clickbaity. That is true. Where did he? Where is he? Where is he? In here, he goes. Boop, boop, boop. Something is faster than real time. Right there, right there. Not bad. 1.6 seconds for 1.8. Whoa! I mean, hold on. He did say it's faster than real time, but it is. I mean, he was based off a recording, so that's why he was saying faster than real time.
5 minutes remaining.
But it's not actually faster than real time because that would require some real fancy engineering. I think that's a little beyond the scope of the O-Scope Wizard. I cannot do time travel. I am not even certain that it is completely feasible. It would be kind of neat, but there are a lot of different implications. Says all my sci-fi. All my sci-fi writers say that. So what did we say? 159.57, I think. I think that's what it said. Let me make sure. 57. It's 86.57, right? 192, 168, 86.57. Can you connect to, I wonder, maybe Schrodinger's cat is doing the train. Maybe. It does feel like super crazy that he would say it's faster than real time. That would be absolutely bonkers. I am re-enabling the SSH server one more time just to see if I'm screwing something up here. It says it's enabled. Now, can I connect to it with my terminal? 192.168.86.57. Yeah, okay. That was weird. Because I have logged into this Raspberry Pi before. You know what? I logged into the old Raspberry Pi before, but it was enabled on the SD card. I wonder if there is some kind of EEPROM on the Raspberry Pi that tracks service. Certainly that wouldn't be the case. That would be like next level. It must be a flag on the SD card, but who knows? Who knows? We're in like Flynn. let's see. The next step. I honestly was kind of surprised. Kind of surprised. The next step, before we get deep into what this guy has done, is to check our re-speaker. And there are actually some instructions on how to do this. And I believe that I have already installed most of this, which took quite a bit of time because it has to actually compile a new kernel with support for this re-speaker voice card. This is the hat that we have sitting on it. If I turn on my camera here, you can see this kind of matches the picture on the website. I got the JST connectors for the speakers and an I2C cable. Sorry, I2C, GPIO 12, JST speakers, and then the audio jack right here, and then two tiny microphones. These little black chips are tiny microphones. And we need to try to make those microphones work. So there is, let's see, there is an example here for how to record. So basically what I want to do is record my voice. Here we go. So I just want to record my voice to something and see if it will play it back, I think. And I'm not really too worried about the coherence yet, because this would be more like direction finding, which might be kind of neat. There's like a bunch of different directions we could go with this project. But I want to start with this. So if I go over to my terminal and I type in a command, can I get this going? A record. And just this will probably bomb out, which is that's fair. That's fair because we're right at the end. No such file. Blah blah blah. Complain, complain, complain. I think I have more instructions. The getting started here. It's saying that I should be able to do this. Hold on, there is a record audio, get audio index. I think I can do that. Sudo Python 3, get audio index, and that should tell me the, let's see if our seed, oh, there it is, the seed mic, whoa! The seed mic system is right there. So it is device 0. I think on the next episode, Guy, the library, yes, thanks. Thanks, Mr. Franks. The library is installed, which disproves it because it is listed. But on the next episode, we should be able to get a recording. That's on Baby Friday, which I'm excited about. Baby Friday, the first day of October, I believe. But we should be able to get a recording and a playback. And then the next step would be trying to get the voice recognition to work. And so maybe our goal for our next episode should be a recording, playback. That will prove that the device is operational and can hear our voice, with the stretch goal of being able to maybe detect a word. Maybe it could detect a couple of words and then print those out on the command line. That would be so cool. I'm just really glad, honestly, that the battery works with the new Raspberry Pi. I don't know what I did to the old, I do know what I did to the old Raspberry Pi, which was destroy it through terrible soldering. If you have awful soldering skills, consider getting a Raspberry Pi with the GPIO pins already installed. And thanks so much for the chat today. I really appreciate it. It helps me stay on track. It helps me answer questions that I have. And if you have a nerd in your life that hasn't seen the show, please share this with them, because I don't know all the nerds, in the world, and I'd love to meet them. I'm going to hang out for a little while in the chat. Maybe you guys can give me some pointers on how to use a mic array and some tips and tricks. I'd love tips and tricks. If you have tips and tricks, share them in the chat. share them in the comments. I will see you guys on Baby Friday. Take it easy. Bye.